I don't know if it's wrong, but it kind of makes me want to cry. If you never regretted the way you designed your APIs, you probably didn't do enough of them. It's almost like writing the code. It seems kind of fine in the moment, and then half a year later you can barely look at it. The only difference is with APIs, there are a lot of people who are already depending on it, and sometimes it's open to the whole world. Luckily, in the world of APIs, there are enough guidelines that usually help, but some of the mistakes, they keep being repeated over and over again. Now, I don't know where you are in your programming journey. Maybe you've never heard of REST APIs, or maybe you've already built some, or maybe you're an API superstar. I'm just going to assume that you work close to web development, and you've probably worked with some REST API endpoints, and maybe you even have some learnings of your own. So let's see if mine are going to be relatable. Throughout the years, I've been working with a lot of APIs. As an API designer, or implementing the server side, or implementing the client side. And I've noticed a bunch of mistakes that people make, and I've probably made a lot more myself. But before we dive in, let me remind you there are probably no absolutes in programming. And some of the things that I describe can be justified either by business requirements or just as a trade-off. Actually, let me know in the comments if you've successfully used any of them so we can all learn from your experience. Let's start with the thing that you see first when you receive a response, the HTTP code. Your API is probably not the only API that your developers are using, so keeping it predictable is a nice thing to do. Let's start with successes. How many times have you seen 200 OK for partial success for an operation that you would have to redo and make some actions? This is kind of okay if you see it as a human, and it may be acceptable if you are working with your own backend and your own front end that can handle this. But if you're building an API for other people to use, this can be very difficult to handle. I think one of the solutions here would be to use a non-standard HTTP code, like 207, and thoroughly document the expected behavior so it's never a surprise for your users. Then we have 201 created on update. You send a patch or put request and you receive an indication that some item was created. That can be very deceiving. Luckily, it's almost never intended. It's usually a copy-paste or a typo, but you would have to watch out for it. Now question, who has created a 200 OK response without any content this year only? That concludes my success section, and we're moving on to errors. Some of you may not believe it, but I've seen it in action. Sometimes 401 and 403 are mixed. And this is extremely confusing. 401 is basically a stranger trying to come into your home. And 403 is your friend coming into your home, but then trying to eat everything in your fridge. Telling your friend that you don't know who he is just because he ate your snacks is kind of extreme, so make sure you're not mixing them. Next on the list is 422 on validation errors. Now, I understand where the thought is coming from. There are errors in your request, that's why we cannot process it, that's why it's an unprocessable entity. This can be quite confusing for the developer on the other end of the API. It's usually for simple validation errors we expect something like 400, and 422 would be reserved for more severe violations. And the last item in my list is not exactly a design problem, but more of an implementation detail. I think the accepted rule of thumb is to treat every 500 as a bug, and if it's not something that's caused by a server error, it would be a different error code. This is very useful for developers because then they know they can fix things. And when I'm getting 500, it's usually a bug report. Oh, that was heavy. Luckily, this one is way shorter. Do not get yourself into the corner by using the solutions that are known as not scalable. Working on developer platform APIs taught me to be very cautious when designing APIs. Every decision that you make will probably stay there for years. It takes a lot of time to deprecate a public version of the API, and all of this time you're not allowed to make breaking changes. But the same can be true for regular APIs, because when you build an API, you get consumers, you get developers who are depending on this API. And sometimes asking them to switch to a new version or make changes is a very heavy business. So how can we avoid it? The first example is very easy, and it's probably taught to everybody who just starts building REST APIs, but I'm going to mention it anyway, is to never use array as a response. Imagine you've built your response with items and it looks great. But then some time passes and you need to add some information that is common for every item on the list. If you're using a dedicated response object that contains an array of items, you can just add your information there. But if you're already returning an array, then you would have to add this information to every item on the list. And it's okay if it's just one line, like a user ID, but sometimes it's a pretty heavy object. But this is usually a minor problem that can be worked around. More challenging problem would be presented by pagination. It can be very tempting to just go with offset pagination. You specify the limit of the items that you're going to get and the offset. Either you start from 0, or you've already requested 10 of them, so you start with 10, and so on and so forth. This can seem like a good choice because it's very understandable and you don't have to explain it to your users. But offset pagination relies on your underlying technology to be able to provide this. And not all of the technologies are capable of it. It is more or less straightforward with relational databases, for example. You still have to worry about the sorting or maybe new items added, but at least you can use a simple SQL command to get exact amount of items that you need. This is the setup they actually had once and it worked great for years, until the moment when we decided to switch from Postgres to DynamoDB. Now getting exact amount of items with exact offset cost so much more resources and money, because we had to either make an additional index or query more items or change the whole structure around one endpoint. That was a disaster that could have been easily prevented if we would have used cursor pagination. In cursor pagination, instead of returning offset and limit, you are returning some encoded string that will be interpreted by the server as the start of the next sequence. The best thing about cursor pagination is that you can still use the same offset as before, but you encode it as a cursor. So when your technical implementation changes, it will probably not even affect your user. The next one is basically, if you know, you know. Compare this number and this number. The main theme in building APIs is that you will not know how they will be used. One thing I can guarantee, they will be used for evil. No, not that. If you're using a numeric ID, it will be read by some system that cannot process it. I've had this problem so many times with REST APIs, with gRPC, with the APIs that I've built, with the APIs that I've used. I wonder if it's one of the most common bug fixes in APIs to switch from a numeric to a string ID. There are more reasons to use string IDs, of course. You're giving yourself the flexibility to change your IDs in the future to whatever you want. It can be that security asks you to change IDs because they think that subsequent IDs are a security risk in your system. Or maybe you are merging two systems together and now you have to introduce some kind of alias that will serve as an ID for both. Or again, you switch the technical implementation and it's more convenient to use string IDs than the number IDs. To keep it short, keep it simple, keep it string. My experience has been affected a lot by working in public APIs, the APIs that companies are offering you to build apps or integrations. There are some specifics to them. For example, you cannot introduce breaking changes because it will break existing apps. It's very difficult to deprecate a version. It's very difficult to figure out the rate limiting to ensure fair use of your APIs. You have to hide the technical implementation because people will start relying on it instead of following your API specifications. You have to focus a lot more on authorization and scopes and preventing the misuse of your APIs. These are not always problems for internal APIs, API between your frontend and backend, or between your microservices. But I believe that starting with expandable and scalable solutions will work better because we can always make them less strict, but going the other way is way more complicated. Let me know if this was useful and share some of the mistakes that you've noticed in different APIs. Maybe I'll stop making them as well.